Mars has always been the planet that fuels our wildest imaginations, a rusty red enigma hanging in the night sky, whispering secrets across millions of miles. But what if I told you the reality of Mars is even stranger than the stories we've dreamed up? Beneath its dusty surface and sweeping valleys, this world has been hiding bizarre, unexplained discoveries that have left even the sharpest scientific minds scratching their heads. From eerie formations that look like they were carved by unseen hands to objects so out of place they defy logic, Mars is a cosmic puzzle box just waiting to be opened. And today, we're diving deep into 30 of the most jaw-dropping, head-scratching mysteries ever uncovered on the red planet. Picture this, a landscape frozen in time where every rock and crater tells a story billions of years old. But scattered among them are things that shouldn't be there, shapes too perfect, structures too precise, shadows that move in ways nature never intended. Some of these findings have sparked heated debates, while others have quietly slipped into NASA archives, labeled simply as unexplained. What if some of these anomalies aren't just tricks of light and geology? What if they're clues to something far bigger, something that could rewrite everything we think we know about our place in the universe? This isn't just a list, it's a journey. A voyage across a world that feels hauntingly familiar yet utterly alien, where every discovery pulls back another layer of mystery. We'll explore everything from the infamous face on Mars to strange metallic objects that gleam in the Martian sunlight, from underground caverns that might hide ancient secrets to fleeting flashes of light that still have no scientific explanation. By the time we're done, you'll see Mars in a whole new light, not just as a barren wasteland, but as a place teeming with unanswered questions. So buckle up, because what we found up there might just blow your mind. Let's begin. The first mystery on our list might be the one that started it all, the so-called face on Mars. Back in 1976, NASA, a Viking 1 orbiter, captured an image of the Cydonia region that sent shockwaves through the scientific community and beyond. What appeared to be a massive, human-like face staring up from the Martian surface became an instant sensation. The formation stretched nearly 2 miles across, with sunken eyes, a pronounced nose, and even what looked like a softly smiling mouth. It was uncanny, eerie, and for many, undeniable proof that Mars had once been home to an intelligent civilization. But here's where things get fascinating. Our brains are wired to recognize faces. It's called pareidolia, the same phenomenon that makes us see shapes in clouds or the man in the moon. And while the face on Mars seemed impossibly detailed in that grainy Viking image, later missions like Mars Global Surveyor and Mars Reconnaissance Orbiter returned with something unexpected. High-resolution photos taken in the late 90s and early 2000s revealed a very different structure. The face was nothing more than a weathered mesa, battered by millions of years of wind and dust. The shadows and angles that once made it look so lifelike vanished under sharper scrutiny. Yet even with scientific explanations, the face on Mars refused to fade into obscurity. Some insisted the later images were doctored, part of a cover-up to hide the truth. Others pointed to nearby formations resembling pyramids or ruins, stitching together elaborate theories about lost Martian cities. But what makes this mystery so enduring isn't just the debate, it's how it reshaped our perspective. Suddenly, Mars wasn't just a dead rock in space. It became a place of infinite possibilities where every strange shadow could hide a secret. And that shift in thinking, that's the real legacy of the face on Mars. Now, let's compare the original Viking shot with the crisp, modern images side by side. The difference is striking. What once looked sculpted now clearly shows the natural chaos of erosion. But here's the kicker, even knowing the truth, part of us still wants to believe. Maybe that's why this particular mystery lingers in our collective imagination, a testament to the tantalizing question, what else is out there waiting to be found? Moving from a face-shaped mesa to something far smaller but no less puzzling, let's talk about the Martian blueberries, tiny, perfectly round spherules that litter the surface like cosmic ball bearings. When NASA Opportunity rover rolled into Eagle Crater back in 2004, its cameras captured something extraordinary. Thousands of these glistening blue-gray orbs, no larger than pebbles, scattered across the rust-colored soil. At first glance, they looked almost manufactured, as if some ancient civilization had dropped a bag of marbles and left them behind. But the truth, as always with Mars, turned out to be stranger than fiction. These blueberries, as scientists affectionately named them, are actually hematite concretions, hardened mineral formations rich in iron oxide. Hematite on Earth often forms in the presence of liquid water, and that's exactly what these tiny spheres hinted at. Analysis revealed they were created billions of years ago when mineral-rich groundwater percolated through porous rock, gradually depositing layers of iron oxide around a central core, like a pearl forming inside an oyster. Over time, wind and erosion wore away the softer rock, leaving the tougher blueberries behind to roll freely across the Martian plains. But here's where the mystery deepens: their near-perfect spherical shape. On Earth, most concretions are lumpy or irregular, shaped by the chaotic flow of water through rock. Mars blueberries, though, they're uncannily uniform, as if shaped by some unseen force. At one point, researchers even floated the idea that they might be fossilized microbial colonies, tiny bubbles of ancient life preserved in stone. That theory didn't hold up under scrutiny, but it sparked a bigger realization. These unassuming little orbs were proof that Mars once had a thriving water cycle. They're time capsules telling the story of a wetter, warmer past where rivers might have flowed and lakes could have shimmered under a pale pink sky. Close-up footage from Opportunity shows just how bizarre these formations are. Some cling to rocks like berries on a bush, others sit alone in the dust, gleaming under the weak Martian sun. Their bluish tint comes from the hematite's unique light-reflecting properties, a stark contrast to the planet's usual rusty palette. And while we now understand their origin, they still raise tantalizing questions. Why are they so concentrated in certain areas? Could their mineral content hint at pockets of underground water even today? Every answer unlocks new mysteries, proving that even the smallest things on Mars can hold the biggest secrets. So while they might not be alien artifacts, the blueberries are far from ordinary. They're remnants of a world that could have been, a Mars that wasn't just a desert, but a place where life might have stood a chance. And that makes them one of the most quietly profound discoveries ever made on the Red Planet. Just when you thought Mars couldn't get any weirder, Curiosity rover stumbled upon a patch of terrain that looked like it was ripped straight from the back of a dragon. Nestled in the foothills of Mount Sharp, this bizarre landscape, nicknamed the Dragon Scales, features rows upon rows of overlapping, plate-like ridges with a texture so reptilian, you'd half expect smoke to curl from between the cracks. The first close-up images sent back to Earth showed surfaces that seemed almost alive, gnarled, ridged, and shimmering under the Martian sun with an otherworldly sheen. So what could possibly create something so fantastical on a planet we once thought was just a barren wasteland? Scientists have two leading theories, and both are just as fascinating as the scales themselves. The first points to ancient volcanic activity. On Earth, similar formations crop up in places like Hawaii, where lava flows cool and contract, fracturing into geometric patterns as they solidify. If Mars had a fiery past, these dragon scales could be the remnants of colossal lava sheets that once oozed across the landscape, hardening into these eerie, armored plates over millions of years. But here's the twist: Curiosity's chemical analysis of the area didn't find the usual volcanic fingerprints. Instead, the rocks were packed with sulfates, minerals that often form in the presence of water. That brings us to the second, even more tantalizing idea. These scales might be the work of water and wind teaming up over eons. Picture an ancient Martian lakebed, its sediments laced with sulfate salts. As the water evaporated, the salts crystallized, binding the sediment into tough, erosion-resistant layers. Then, billions of years of sandblasting winds went to work, sculpting the softer rock away and leaving behind these raised, interlocking ridges. It's a process we've seen in places like Utah's Badlands, where water and wind carve Earth's rock into surreal, layered masterpieces. But on Mars, the lack of vegetation and weather extremes might have amplified the effect, creating scales so pronounced they look almost designed. Zooming in on Curiosity's footage, the detail is staggering. Some ridges cast long, claw-like shadows, while others curl at the edges like charred parchment. The way light plays off their surfaces changes throughout the Martian day, making the ground seem to ripple like the hide of some sleeping beast. And that's the real magic of this discovery. It's not just about solving a geological puzzle. It's about how Mars keeps blurring the line between science and myth, between the explainable and the utterly surreal. Whether forged by fire or shaped by water, these scales are a reminder that Mars isn't just a static museum of rocks. It's a dynamic storyteller, whispering tales of its tumultuous past in a language of stone and wind. And with every new snapshot from Curiosity, we're learning to listen a little better. One of the most head-scratching moments in Martian exploration came when Opportunity, the little rover that could, suddenly spotted a rock that seemed to materialize out of thin air. The scene was familiar, just another patch of dusty terrain in Meridiani Planum, a region the rover had been studying for years. But when scientists compared images taken 12 days apart, there it was, a smooth, white-rimmed rock roughly the size of a jelly donut, sitting defiantly where nothing had been before. Dubbed Pinnacle Island, this mysterious visitor sparked a firestorm of speculation. How does a rock just appear on a planet with no known geological activity? Initial theories ranged from the practical to the downright surreal. Some team members suggested Opportunity's wheel might have kicked it up while maneuvering, flipping the rock into view. Others proposed wind could have nudged it downhill from a nearby outcrop. But here's the catch: Pinnacle Island wasn't just any rock. Close-up analysis revealed a composition unlike anything else in the area. A bright white exterior with a deep red center, like a cosmic candy with a bizarre filling. The white portion was packed with sulfur and magnesium, while the red interior showed sky-high levels of manganese, a combination so odd it left geologists scrambling for earthly comparisons. Then came the skeptics. Could this be a piece of human-made debris, a fragment from Opportunity's own landing hardware that had lain hidden for years? The rover's earlier twin, Spirit, had encountered similar phantom objects, bits of insulation or broken parts from their descent stages. But Pinnacle Island's mineral makeup didn't match any known spacecraft materials. That left one spine-tingling question: was this rock evidence of a process we've never seen before? Some researchers floated the idea of a meteorite impact nearby, ejecting fragments across the plain. Others whispered about underground forces like ancient geysers or shifting salts, pushing buried rocks to the surface. Zooming in on the images, the rock's texture only deepened the intrigue. Its smooth, almost polished surface suggested it had been weathered by something stronger than Martian winds, perhaps liquid water in the distant past. And its sudden appearance, a reminder that Mars is anything but static. Even after decades of study, the planet keeps serving up puzzles that defy easy answers. So while Pinnacle Island was eventually traced to a likely wheel flick, its brief moment in the spotlight revealed something bigger. Mars isn't just a collection of rocks, it's a dynamic world where even the smallest surprises can rewrite the questions we ask. And for a rover designed to last 90 days, surviving over a decade to witness such a moment, that's the real Martian magic. And then there's the case of the Mars rat, a tiny, fuzzy-looking rock that sent the internet into a frenzy back in 2013. When Curiosity rover beamed back a curious close-up of a shadowy nook in Gale Crater, eagle-eyed viewers zeroed in on what appeared to be a rodent, perched on the rocks like some interstellar taxidermy project. The creature had a rounded back, pointy nose, and even what looked like tiny ears. Memes exploded overnight, with jokesters dubbing it the first Martian pet and conspiracy theorists declaring it proof NASA was hiding alien wildlife. But as always, Mars had a reality check up its sleeve. The so-called rat was just a small, weathered rock, no bigger than a human fist whose contours happened to align perfectly with the lighting and camera angle to mimic fur and whiskers. Shadows pooled in its crevices, creating the illusion of depth, while its tapered shape tricked our brains into seeing a snout. It's a classic case of pareidolia, the same quirk that makes a spot bunnies in clouds or faces in toast. But what's fascinating isn't just the optical illusion, it's why we wanted it to be real. The Mars rat tapped into a deeper longing, the hope that Mars isn't just a desert, but a place where life, even scrappy little space rodents, could thrive. Side-by-side images tell the real story. Rotate the rock's image by just a few degrees, and the rodent morphs back into an unremarkable stone. Yet the impact of that momentary illusion speaks volumes. For centuries, we've projected Earth's imagery onto Mars, canals, faces, even forests, because we crave kinship with the cosmos. The rat wasn't just a meme, it was a mirror, reflecting our stubborn refusal to see Mars as lifeless. Even NASA leaned into the fun, with one team member quipping, "If there's a rat on Mars, it must have hitchhiked from Earth." But buried beneath the jokes is a kernel of scientific truth. If a simple rock can ignite such wild speculation, what happens when we do find something truly inexplicable? The Mars rat reminds us that every pebble on that planet is a Rorschach test, and sometimes the most revealing discoveries aren't on Mars at all, but in how we choose to see them. Amid the endless rust-colored dunes of Gale Crater, Curiosity rover's camera caught something that glinted like a misplaced piece of jewelry, a small, metallic-looking lump sitting defiantly in the dust. Dubbed the shiny object, this peculiar formation stood out like a diamond in a sandpit, its surface reflecting sunlight with an intensity unlike anything else in the vicinity. At first glance, it seemed almost placed there, as if someone had dropped a polished trinket on their way through. But Mars doesn't do coincidences, and this gleaming anomaly quickly became a magnet for scientific curiosity. So what exactly was it? Researchers scrambled to explain the object's unusual sheen, floating three compelling theories. The first and most dramatic, a meteorite. Mars' thin atmosphere does little to burn up incoming space rocks, leaving the surface littered with metallic fragments from billions of years of impact. The object's reflective surface and smooth edges fit the bill, resembling iron-nickel meteorites found on Earth. But here's the twist: Curiosity's laser spectrometer, designed to zap rocks and analyze their composition, couldn't get a clear reading. The glint was so intense it scattered the laser's light, leaving scientists squinting at inconclusive data. Then came the volcanic glass hypothesis. On Earth, volcanic eruptions can produce obsidian, a natural glass forged from rapidly cooled lava. If Mars had similar eruptions in its fiery past, this shiny lump could be a remnant, its surface polished smooth by eons of wind-blown sand. The problem: most Martian volcanic rock discovered so far has been porous and weathered, not mirror-smooth. Unless this was a freakishly well-preserved relic, the glass theory left gaps. And then there's the mundane but plausible, a camera artifact. Sunlight hitting Curiosity's own hardware, a bolt, a bracket, even a fleck of debris on the lens, could create the illusion of a distant, glowing object. But when engineers mapped the rover's position against the object's location, nothing matched. The glint wasn't coming from the machine. It was out there in the wilds of Mars, doing its best impersonation of a sci-fi prop. Zooming in on the images, the contrast is striking. The surrounding soil is dull and powdery, typical of Mars' iron-rich regolith. But this object, it's like a drop of liquid mercury frozen in time, reflecting the sky with eerie precision. Some researchers even floated the idea of man-made contamination. Could it be a shred of debris from Curiosity's landing? But the rover hadn't passed through that area before, and the object's composition, as best they could tell, didn't match any spacecraft materials. What makes the shiny object so captivating isn't just the mystery of its origin. It's the way it forces us to confront how little we truly understand about Mars. Even our most advanced rover, equipped with lasers and high-resolution cameras, can stumble across something that defies immediate explanation. Is it a cosmic visitor, a geological oddity, or just a trick of the light? For now, it remains a gleaming question mark on the red planet's surface, a reminder that Mars still has plenty of secrets left to reveal. Among the many oddities Curiosity rover has uncovered, few sparked as much instant fascination as the so-called doorway on Mars, a near-perfect rectangular crevice carved into the rock face of Mount Sharp. When the image hit the internet in 2022, it looked like something straight out of science fiction, a sharply defined opening just tall enough for a person to walk through, flanked by smooth walls that seemed almost engineered. Social media erupted with theories: ancient alien architecture, secret bunkers, even portals to underground civilizations. But as always with Mars, reality turned out to be just as mesmerizing as myth. What makes this formation so uncanny is its precision. Natural rock fractures tend to be jagged or irregular, shaped by chaotic forces like earthquakes or erosion. But this crevice, its right angles and parallel sides look manufactured, as if chiseled by tools rather than time. Geologists quickly stepped in with an explanation: shear fracturing. On Earth, similar formations occur when layers of sedimentary rock, stacked like a cake over millions of years, undergo stress. If one layer is harder than the others, it can crack cleanly along straight planes as the ground shifts. Add a few million years of wind sandblasting the edges smooth, and voila, a doorway that tricks the eye. To visualize this, imagine snapping a slab of slate in your hands. The break isn't random, it follows the natural grain of the rock, now scaled that up to Martian proportions, with cliffs hundreds of feet tall, subjected to temperature swings of nearly 200 degrees between day and night. Rocks expand and contract like breathing lungs, creating fractures so precise they defy intuition. Overlay diagrams of these fracture mechanics, and the mystery starts to unravel. The doorway isn't an entrance, it's a geological snapshot, a moment frozen in stone where pressure met resistance and lost. Yet even with the science laid bare, the illusion lingers. Shadows pool inside the crevice, deepening its resemblance to a passageway. The surrounding rock face, weathered into stepped layers, looks eerily like ruins. It's a masterclass in how Mars plays tricks on us, blending the familiar with the alien. And that's the real magic here. Not that we mistook a crack for a door, but that Mars keeps giving us reasons to look twice. Every time we think we've seen it all, the red planet carves another puzzle into its cliffs, daring us to wonder what if, just once, we're not imagining things. Hidden among the jagged rock formations of Mars' Cydonia region lies another shape that has fueled decades of wild speculation: the so-called Sphinx of Mars. Spotted in the same 1976 Viking mission images that captured the infamous face, this pyramid-like structure rises from the Martian plains with an almost architectural symmetry. Its four sloping sides and flat top mirror the Great Pyramid of Giza at a fraction of the size, measuring roughly 100 yards across. At first glance, it looks deliberate, as if some ancient stonemason had etched their mark into the rusty terrain. But as with all things on Mars, the truth is buried beneath layers of time, wind, and our own yearning to see meaning in the void. Geologists point to earthly analogues to demystify the Sphinx. In deserts like Namibia's Namib Rand or Arizona's Monument Valley, wind-sculpted buttes and mesas often take on geometric shapes. Over millennia, gusts carrying fine sand act like nature's sandpaper, wearing softer rock away while leaving harder layers intact. The result, structures with eerily straight edges, nature's version of a cosmic chisel. Mars, with its thinner atmosphere but relentless global dust storms, amplifies this effect. Without liquid water or tectonic shifts to complicate erosion, wind becomes the primary artist, carving the landscape with patient mathematical precision. Satellite overlays comparing the Sphinx to Earth's wind-carved formations reveal nearly identical angles and weathering patterns, yet no explanation can fully extinguish the allure of the Sphinx as proof of a lost Martian civilization. The human brain is wired for pattern recognition, a survival trait called pareidolia that helped our ancestors spot predators in dense foliage. Today, it makes us see faces in electrical outlets and animals in passing clouds. When applied to Mars, this instinct goes into overdrive. The Sphinx's crisp edges trigger our sense of intentionality, while its isolation, perched like a sentinel on the plains, fuels narratives of ruins waiting to be excavated. Psychologists call this agent detection bias, our tendency to attribute unexplained phenomena to conscious actors rather than random chance. It's the same impulse that once made sailors see mermaids in floating kelp. What makes the Sphinx uniquely fascinating, though, isn't just its shape, it's the company it keeps. Nearby, the Martian surface is littered with smaller, pyramid-like rocks and linear ridges that some interpret as collapsed walls or roads. Viewed together through the lens of imagination, it's easy to paint a picture of a vast, buried city, but scientific scrutiny reveals a different story. High-resolution scans from the Mars Reconnaissance Orbiter show these ruins are nothing more than eroded mesas, their straight lines the result of layered sedimentary rock fracturing along predictable plains. The real magic lies in how perfectly Mars mimics the aesthetics of artifice, blurring the line between geology and fantasy. So while the Sphinx isn't a monument to alien architects, its existence reshaped how we explore. Every new Mars mission now carries tools to scrutinize these anomalies with forensic precision, lasers to vaporize rock, spectrometers to read mineral signatures, and algorithms to map erosion patterns. In debunking one mystery, the Sphinx gave us something greater, a blueprint for separating Martian daydreams from genuine discovery. And who knows, maybe one day, amidst the countless wind-sculpted rocks, we'll find one that defies even the sturdiest scientific scaffolding. Until then, the Sphinx stands as a testament to both the power of nature and the stubbornness of human wonder. Amid the dusty, wind-scoured terrain of Gale Crater, Curiosity rover's camera once zoomed in on something delicate, a tiny, flower-like formation no larger than a penny, its petals splaying outward like coral frozen in stone. Dubbed the Mars flower, this fragile-looking structure sparked instant debate. Was it fossilized life, a bizarre mineral accident, or something even stranger? The truth lies in chemistry, not biology. This otherworldly bloom is a diagenetic feature, a mineral deposit formed when water percolated through Martian rock billions of years ago, leaving behind crystal clusters as it evaporated. On Earth, similar formations crop up in places like New Mexico's Lechuguilla Cave, where gypsum flowers sprout from walls in intricate curling tendrils. But Mars' version is made of something tougher, sulfates, likely jarosite or gypsum, minerals that thrive in acidic, watery environments. Close-ups reveal the petals are actually microscopic crystal aggregates, their branching patterns dictated by the slow dance of mineral-rich fluids seeping through cracks. What makes this discovery so compelling isn't just its beauty, it's the story it tells. The flower's intricate shape hints at persistent water activity, not just brief floods. Think of it like a bathtub ring, but instead of soap scum, it's minerals left behind by countless wet-dry cycles. Each layer of crystallization is a timestamp, a whisper from an era when Gale Crater might have been a shimmering lakebed. And while it's not proof of life, it does point to environments where life could have gained a foothold. Yet the illusion of life is uncanny. Side-by-side comparisons with earthly coral or certain lichens show eerie parallels, nature converging on similar designs across worlds. That's the real magic of the Mars flower. It's a Rorschach test for our hopes, a tiny Rembrandt painted by geology, reminding us that even in the harshest deserts, beauty finds a way. Among the countless rocks littering Mars' surface, Curiosity rover once spotted something that seemed to defy physics. A slender, spoon-shaped formation hovering precariously over the dust, its handle attached to nothing but thin air. The image, snapped in 2015, looked like a scene from a cartoon, a utensil frozen mid-dangle, as if some cosmic diner had set the table and vanished. Social media erupted with jokes about Martian tea parties, but the truth behind this gravity-defying oddity is a masterclass in how wind and time can sculpt the impossible. So how does a spoon just float on Mars? The answer lies in differential erosion, a process where softer rock wears away faster than harder layers. Picture a sandstone cliff on Earth, where centuries of rain carve out alcoves beneath tougher overhangs. Mars does the same thing, but with wind as its chisel. The planet's thin atmosphere still packs enough force to send dust storms racing across the landscape at hundreds of miles per hour, sandblasting everything in their path. When these gusts encounter a rock with alternating hard and soft layers, they eat away at the weaker material, leaving behind delicate arches, bridges, and in this case a spoon-shaped illusion. Scientists recreated the process in simulations, speeding up millions of years of erosion into mesmerizing slow-motion sequences. The models show how a seemingly ordinary rock, once buried, can emerge as a surreal silhouette as surrounding sediment is stripped away. The spoon's handle is actually a fragile tendril of more resistant rock clinging to its main body until the moment, perhaps soon, when even Martian winds finally snap it loose. What makes this phenomenon so captivating isn't just the optical illusion. It's the fleeting nature of these formations. Unlike Earth, where water and vegetation constantly reshape landscapes, Mars preserves its wind-carved sculptures for eons. That spoon might hover unchanged for millennia, a testament to the patience of geological forces. Yet it's also a reminder that every strange shape we spot is a snapshot in an endless process of creation and destruction. Zooming in on Curiosity's images reveals even more nuance. The spoon's bowl casts a crisp shadow, proving it's truly detached, while its surface gleams with a subtle polish from countless dust collisions. Nearby rocks show similar wear patterns, their underbellies scooped out like melted ice cream. It's a gallery of natural art, each piece shaped by the same invisible hand. So while Mars might not have a secret kitchen hidden in its craters, the floating spoon is proof that reality can outdo even our wildest imaginations. Who needs alien architects when wind and time can craft such perfect illusions? And somewhere out there, another improbable shape is waiting to be uncovered, another trick of the light and landscape that'll make us question everything we think we know about the red planet. High above Mars' surface, NASA, a high-rise camera captured an image that sent conspiracy theorists into overdrive, a towering, rectangular slab of rock jutting from the dust like some ancient alien obelisk. Dubbed the Mars monolith, this stark formation rises nearly 15 feet tall, its sharp angles and flat faces appearing almost manufactured against the chaotic terrain of the Phlegra Montes region. At first glance, it looks like a deliberate marker, a cosmic X on a treasure map left behind by some long-gone civilization. But before we start drafting invitations for extraterrestrial archaeologists, let's unpack what's really casting that eerie shadow across the Martian plains. Geologists have a far less sensational explanation: jointed bedrock. On Earth, massive rock formations like Devil's Tower in Wyoming or Ireland's Giant's Causeway form when cooling lava contracts, fracturing into geometric columns over millions of years. The same process likely sculpted the Mars monolith. Imagine a vast sheet of volcanic rock, once molten and bubbling beneath the surface. As it cooled, internal stresses caused it to crack along precise planes, leaving behind these cathedral-like pillars. Wind erosion then sandblasted the surrounding softer material away, isolating the toughest remnants, nature's version of a stone sculptor chiseling away excess marble. High-rise zoomed-in images revealed telltale vertical striations along the monolith's sides, textbook evidence of this fracturing process at work. But here's where the mystery deepens. The monolith's near-perfect rectangular profile is unusual even for jointed bedrock. Most natural columns are hexagonal or pentagonal, shaped by the physics of cooling magma. A perfect right-angled block, that's rarer. Some researchers suggest it could be a cleaver, a massive fragment sheared off by tectonic shifts long ago, then weathered into its current form. Others point to the possibility of sedimentary layers, where alternating hard and soft rock strata eroded at different rates, leaving behind a stepped, blocky remnant. Detailed spectral analysis shows the monolith's composition matches the region's basalt, further grounding it in Mars' volcanic past. Yet the allure of the monolith isn't just about its shape, it's about placement. Perched atop a barren plain, it stands in stark isolation, like a lone sentinel guarding nothing. This too has earthly parallels. Utah's Fisher Towers or Australia's Totem Pole are freestanding rock spires shaped by wind and water, their bases whittled away until only the most resilient stone remains. On Mars, without rain or vegetation to complicate erosion, the process is distilled to its purest form. Time-lapse simulations of wind patterns in Phlegra Montes show how persistent gales could carve such a solitary monument over eons, grain by grain. Of course, no discussion of the monolith would be complete without addressing the elephant in the room, its uncanny resemblance to the black monolith from 2001, A Space Odyssey. Pop culture has primed us to see these shapes as alien artifacts, and Mars delivers the perfect canvas for our projections. It's a psychological double whammy. Our brains are wired to spot straight lines, a trait that helped early humans identify tools or predators, and our love of narrative twists ambiguous geology into something intentional. Even renowned physicist Dr. Brian Cox once quipped, "If you wanted to build a monolith somewhere, Mars would be the place to do it." Scientific debunking hasn't stopped the speculation, though. Some theorists insist the monolith is too perfectly proportioned to be natural, citing mathematical precision in its dimensions. Others claim nearby rocks form cryptic alignments, hinting at a larger, buried structure. But orbital imagery tells a different story. Wider shots of the area reveal dozens of similar, less photogenic formations, jagged pillars, and fractured mesas that didn't go viral because they lacked the monolith's cinematic flair. It's a reminder that Mars is a world of extremes, where geology routinely conjures shapes that challenge our sense of plausibility. What makes this particular rock so captivating isn't just the debate it sparks, but the questions it forces us to confront. How do we distinguish the truly anomalous from the merely unexpected? When does scientific caution become a reluctance to entertain radical ideas? The monolith sits at that crossroads, a Rorschach test for how we explore the unknown. For now, it's classified as a fascinating quirk of nature, but like all great Martian mysteries, it leaves just enough room for wonder, and who knows? Maybe one day a rover will roll up to its base, brush away the dust, and find something written in the stone after all. Tucked among the rippling dunes of Mars' Gale crater lies a rock formation so uncanny, it stopped scientists mid-scroll, a long, curved fragment resembling nothing so much as the bleached rib cage of some long-dead Martian leviathan. Dubbed the whalebone, this eerie structure stretches nearly 3 feet across, its smooth arcs and tapered ends looking like they were plucked straight from a paleontology dig site. When Curiosity rover beamed back the first close-ups, the internet erupted with theories. Was this proof Mars once swam with life? had we finally stumbled upon the fossilized remains of an alien creature. But the truth, as always with Mars, is a masterclass in how geology can mimic biology with startling precision. The whale bone isn't a fossil, it's a textbook example of ventifact, a rock sculpted by wind into shapes that deceive the eye. On Earth, similar formations pepper deserts like Namibia's Skeleton Coast, where gusts laden with sand carve sandstone into sinuous ridges and hollows. The process is slow but relentless. Imagine a sandblaster set to its gentlest setting, running for millions of years. Each microscopic grain chips away at the rock's weakest points, following the path of least resistance. Softer minerals erode faster, leaving behind harder layers that take on fluid, almost organic contours. What makes the whale bone special is its composition. Curiosity's laser spectrometer revealed it's rich in silica, a mineral exceptionally resistant to erosion. Scientists suspect it might be the remnant of an ancient fracture network, where mineral-rich groundwater once seeped through cracks in the rock, depositing silica like cement in the gaps. Over eons, wind scoured away the surrounding material, exposing this hardened skeleton. The curve, pure chance, a quirk of how the original fracture meandered through the stone. Side-by-side comparisons with earthly ventifacts are revelatory. In Chile's Atacama Desert, wind-polished rocks twist into bone like spirals. In Arizona's Coyote Buttes, sandstone warps into fluid waves frozen in mid-motion. The whalebone fits right into this gallery of natural illusion. Even its color plays tricks. Mars' ubiquitous iron oxide dust clings to its crevices, deepening shadows to mimic the marrow cavities of real bones. Yet for all the scientific explanations, there's poetry in the deception. The whalebone forces us to confront how alive a dead world can seem. Every contour whispers of movement, as if the rock remembers the winds that shaped it. And who knows, maybe one day, among the countless ventifacts littering Mars, we'll find one that doesn't fit the geological mold. Until then, the whalebone stands as a testament to nature's flair for drama, a sculptor that doesn't need life to create its masterpieces. Mars never runs out of ways to surprise us, and the so-called tadpole crater is proof. Nestled in the southern highlands, this peculiar formation looks like something straight out of a child's sketchbook, a near-perfect circular depression with a long, winding tail trailing behind it, as if a cosmic tadpole had once splashed down and left its mark. At first glance, it's almost whimsical, but the forces that shaped this bizarre feature were anything but gentle. The leading theory, ancient flowing water. Imagine a time, billions of years ago, when Mars wasn't the frozen desert we see today. Picture torrential rains or melting ice sheets sending water gushing across the landscape with enough force to carve canyons and scour plains. Now zoom in on one particular impact crater, a fresh wound in the Martian crust. As water rushed over its rim, it would have sought the path of least resistance, eroding a channel along one side and carrying debris downhill. Over millennia, that relentless flow could have sculpted the crater's tail, leaving behind a serpentine groove that stretches for miles. Satellite images reveal telltale signs of this process. The tail's bed is lower than the surrounding terrain, and its walls slope inward, classic hallmarks of fluid erosion. But water isn't the only suspect. Some planetary scientists argue the tail might be the work of lava, not H2O. On Earth, similar formations crop up near volcanoes, where molten rock oozes through cracks and solidifies into sinuous tubes. Mars' volcanic past is well documented. Just look at Olympus Mons, the solar system's largest volcano. If lava once breached the crater's rim, it could have flowed downhill, leaving behind a hardened tail of basalt. Spectral data adds fuel to this theory. Certain mineral signatures along the groove hint at volcanic origins. To visualize how this might have unfolded, think of honey dripping off a spoon. The initial drop, the crater, forms a perfect circle, but as the stream flows downward, it pulls material with it, stretching the formation into something elongated and organic. Now scale that up to planetary proportions, with lava or water replacing the honey and time stretched over epochs. The result, a tadpole frozen mid-swim, its tail capturing a single moment in Mars' chaotic hydrological or volcanic past. What makes this formation so compelling isn't just the debate over its origins. It's the way it forces us to reimagine Mars as a world of motion and change. That tail didn't form overnight. It's a relic of a time when the planet pulsed with energy, when its surface was reshaped by forces as dynamic as any on Earth. And somewhere beneath the dust, there might be more of these strange signatures waiting to be found, each one a clue to unraveling the red planet's most enduring mysteries. Near Mars' south pole, the landscape transforms into something straight out of a sci-fi nightmare. A sprawling web of dark, spindly channels that branch outward like frost creeping across a window pane. But this is no delicate frost. Dubbed the frozen spider terrain, these eerie formations stretch for miles, their tendril-like arms radiating from central hubs as if some colossal arachnid had pressed itself into the ice. When high-resolution images first beamed back from orbit, the patterns seemed almost alive, their inky veins stark against the blinding white carbon dioxide ice. And in a way, they are alive, not with biology, but with the restless energy of a planet that never stops changing. What creates these haunting designs? The answer lies in the bizarre behavior of Martian seasons. During winter, temperatures at the poles plummet to -190 degrees Fahrenheit, cold enough to freeze carbon dioxide straight out of the thin atmosphere. Layer upon layer of dry ice builds up, blanketing the ground in a slab that can be several feet thick. But when spring arrives, something extraordinary happens. Sunlight penetrates this translucent ice, heating the darker soil beneath. That warmth travels back upward, turning the solid CO2 at the base of the ice sheet directly into gas, a process called sublimation. Trapped beneath the ice, this gas builds pressure until it finally fractures the frozen ceiling, exploding upward in geysers that blast dust and ice crystals high into the sky. The spiders are the scars left behind by this violent cycle. Each time gas bursts through, it carves a new channel in the surface, fanning outward like cracks in shattered glass. Over centuries, these fractures grow and intersect, etching intricate patterns into the ground. Time-lapse images from orbit reveal the process in action, dark tendrils spreading like ink in water as the seasons shift. Some spiders even seem to move, their limbs extending year after year as fresh eruptions gnaw at the landscape. What's truly mind-bending is the scale. Individual channels can be dozens of yards wide, while entire spider networks span areas larger than cities. Side-by-side comparisons with earthly phenomena, like the thermal erosion patterns in Siberia's permafrost or the gas vents under Iceland's glaciers, show eerily similar designs. But Mars takes it to extremes, with none of Earth's liquid water or vegetation to soften the effect. The result is a landscape that looks both alien and eerily familiar, like nature doodling in a sketchbook with impossibly dark ink. Yet the spiders still guard mysteries. Why do some channels branch at near-perfect 60-degree angles, as if following some hidden geometric rule? Could underlying rock formations guide the gas like invisible pipes? And what about the baby spiders, smaller, fainter patterns that cluster around larger ones, suggesting this process operates at scales we're only beginning to map? Every new orbiter pass adds detail, but Mars keeps its secrets close. For now, the frozen spider terrain stands as a reminder that even in its coldest corners, Mars is anything but static. It's a world where ice doesn't just melt, it vanishes into thin air, where gas sculpts the land like an invisible chisel, and where every spring brings a fresh eruption of artistry. So the next time someone calls Mars a dead planet, point them south. There, beneath the shifting ice, the ground itself is breathing. Buried in the rusty sands of Meridini Planum, Opportunity Rover rolled up to a site that seemed plucked from a cosmic bowling alley, a single, impossibly round rock sitting alone in the dust like a misplaced cannonball. This wasn't just another pebble, it was a perfect sphere, so symmetrical it looked polished by invisible hands. Dubbed the Mars Cannonball, this uncanny formation immediately sparked comparisons to Earth's own geological oddities, Moqui marbles, the iron-rich spheres scattered across Utah's deserts. But how does nature sculpt something so precise on two worlds separated by millions of miles? The answer lies in one of the universe's most patient artists, liquid water. On Earth, Moqui marbles form when groundwater rich in iron oxide seeps through porous sandstone. Over millennia, the iron precipitates out, coating grains of sand layer by layer until they harden into spherical concretions. Erosion eventually wears away the softer surrounding rock, freeing these metallic marbles to roll across the landscape. The Mars Cannonball likely followed a similar script billions of years ago, when Mars was a wetter world, mineral-laden water percolated through cracks and pores in the bedrock. As conditions changed, perhaps as the planet dried or froze, those minerals crystallized around a central nucleus, a speck of dust or a tiny rock fragment growing outward in all directions with mathematical precision. Without the chaotic interference of wind or shifting sediment, the concretion could form in near-perfect symmetry, a testament to the slow, steady work of chemistry. High-resolution images from Opportunity reveal mesmerizing details. The cannonball's surface isn't just smooth, it's textured with a fine-grained pattern that hints at its layered origin. Spectral analysis confirmed it's rich in hematite, the same iron oxide that gives Mars its rusty hue and Earth's Moqui marbles their metallic sheen. But here's where the Martian version gets even stranger. While Earth's marbles are usually clustered, Mars' cannonball sat in eerie isolation, as if placed there deliberately. Scientists suspect it might have tumbled from a nearby outcrop, carried by ancient floods or landslides, then left behind as the softer rock around it weathered away. Zooming out, this unassuming sphere is more than a geological curiosity, it's a time capsule. The very presence of hematite concretions suggests Mars didn't just have fleeting puddles, it had persistent groundwater, the kind that lingers long enough to forge such intricate structures. That's a game-changer in the search for past life. On Earth, similar environments teem with extremophiles microbes that thrive in mineral-rich, watery niches. Could the cannonball's creators have been Martian microbes? Probably not. But the conditions that shaped it, those might just have been hospitable enough for life to take root. Side by side with Utah's Moqui marbles, the similarities are striking: same spherical silhouettes, same iron-rich composition, but the differences are just as telling. Earth's marbles often cluster like grapes, while Mars' version seems to prefer solitude. Wind and rain on Earth give concretions a frosted, matte finish. Mars' thin atmosphere leaves its spheres oddly pristine, their surfaces etched only by the gentlest dust devils. It's a study in contrasts, two worlds playing the same geological tune but in different keys. So while the Mars Cannonball isn't some alien artillery, it's far from ordinary. It's a relic of a planet that once brimmed with possibility, a tiny orb that holds the echo of ancient rivers and the whisper of a time when Mars might have been almost Earth-like. And somewhere out there in the dust, there are undoubtedly more of these cosmic marbles waiting to be found, each one a silent reminder that the universe has a knack for repeating its greatest hits. Among the countless craters dotting Mars' surface, one stands out for its bizarre, almost architectural symmetry, the so-called Mars Waffle. Nestled in the plains of Amazonas Planitia, this peculiar formation features a near-perfect grid of raised ridges, crisscrossing the crater floor like the imprint of a giant breakfast iron. When NASA Mars Reconnaissance Orbiter first captured high-resolution images of this geometric marvel, it looked anything but natural. The precision of those intersecting lines, some stretching over 100 yards, seemed too deliberate, too engineered to be the work of random geological forces. But as always with Mars, the truth is a fascinating blend of science and serendipity. Two leading theories attempt to explain this waffle-like wonder, and both hinge on the planet's volatile past. The first points to ancient lava tubes. Mars was once a world of fire as much as ice, its surface scarred by eruptions that dwarfed anything on Earth. When molten lava flows, it often leaves behind hollow tunnels, tubes where the outer layer cools and hardens while the interior remains liquid, draining away to form subterranean channels. Over time, the ceilings of these tubes can collapse, creating surface depressions that intersect like lines on a grid. Satellite overlays comparing the waffle pattern to known lava tube networks on Earth show eerie similarities with the same angular junctions and linear scarring. But there's another, even chillier possibility: polygonal terrain. In Mars' polar regions and mid-latitudes, freezing and thawing cycles driven by seasonal shifts in temperature can fracture the ground into geometric patterns. It's a process akin to the cracks that form in drying mud or the hexagonal tiling of Arctic permafrost. When subsurface ice expands, it stresses the overlying soil, creating tension that resolves in straight-line fractures. Repeat this over millennia, and you get a sprawling honeycomb of cracks. The waffle's location, far from the poles but in a region known for buried ice, makes this theory compelling. Spectral data even hints at water ice lurking just beneath the crater floor, adding weight to the idea that this grid might be the work of frost, not fire. Zooming in on the orbiter's footage reveals even more nuance. The ridges aren't uniform, some appear weathered, their edges softened by dust, while others remain sharp as if freshly exposed. This suggests the waffle isn't a single event phenomenon but a layered record of Mars' climatic swings. Imagine freeze-thaw cycles stacking like pages in a book, each winter adding new fractures, each summer filling them with wind-blown grit. Over time, the most resilient ridges emerge as the waffle's grid lines, while the gaps fill in to create that uncanny breakfast food aesthetic. What makes this formation so mesmerizing isn't just the debate over its origins, it's the sheer scale of its precision. The waffle's cells average around 30 feet across, their angles hovering near 120 degrees, a geometric efficiency seen in everything from beehives to basalt columns. Nature loves efficient shapes, and Mars is no exception. Yet there's also an element of illusion at play. From space, the grid appears flawless, but rover-level views would likely reveal a messier reality: jagged cracks, slumped edges, and debris-choked corners. It's a reminder that Mars loves to tease us, serving up just enough order to spark our curiosity, then tossing in chaos to keep us guessing. So whether sculpted by bubbling lava or cracking ice, the Mars waffle stands as a testament to the planet's knack for turning mundane processes into something extraordinary. It's not a relic of alien landscapers, but it is proof that even in the starkest deserts, nature has a flair for the dramatic. And somewhere out there, another crater might just be hiding its own version of cosmic syrup to complete the breakfast analogy. Mars holds onto its past in the strangest ways, like the haunting impressions left behind by colossal dunes that vanished billions of years ago. Scattered across regions like Noctis Labyrinthus and Hellas Basin, these phantom landforms appear as eerie crescent-shaped depressions, their curves etched into the rock like footprints of long-dead giants. Scientists call them ghost dunes, and they're some of the most poetic relics the red planet has ever revealed. Imagine towering waves of sand, some reaching heights rivaling skyscrapers, marching across an ancient Martian desert. Over time, gusts of wind sculpted their surfaces into sharp crests and sweeping slip faces, just like modern dunes on Earth. But here's where the story twists. Volcanic ash or mineral-rich water seeped into the dunes' bases, saturating the sand with cement like silica or iron oxides. As eons passed, the very sediments that once shifted with the wind hardened into rock, freezing the dunes' silhouettes in place. Then, the unthinkable happened: the dunes themselves vanished. Winds scoured away their unburied tops, leaving only their petrified skeletons behind. Today, these crescent-shaped molds stand as hollow echoes of a lost landscape, their once lofty peaks now just empty voids in the bedrock. Earth has its own ghostly analogues, like Utah's dune ghosts, where Jurassic-era dunes were similarly preserved in stone, but Mars takes the phenomenon to extremes. Orbiter images reveal ghost dunes stretching for miles, their shapes so crisp they look freshly pressed. Some even cluster in dune graveyards, their crescent tips pointing in the same direction like fossilized wind veins, hinting at ancient atmospheric patterns. Zoom in and you'll spot finer details, ripple marks on their flanks preserved as delicate ridges, and even the faint scars of smaller dunes that once climbed their slopes. These aren't just static imprints, they're snapshots of a dynamic past, capturing moments when Martian winds howled across a world in motion. What makes these ghosts so haunting isn't just their beauty, it's what they whisper about Mars' climate saga. Their curves suggest winds strong enough to shape dunes but not to erase them entirely, pointing to a time when the atmosphere was thicker, perhaps even capable of sustaining liquid water. And nestled between their crumbling walls, scientists have found sheltered micro-environments, pockets where life, if it ever existed, might have found refuge from the planet's harsh surface. So while these dunes are long gone, their shadows endure, a reminder that even the most fleeting features can leave eternal marks. And somewhere beneath the dust, Mars might still hide older, stranger ghosts waiting to tell their stories. Deep inside one of Mars' shadowy caverns, a camera captured something that looked like it belonged in a fantasy novel, a towering, spike-like protrusion jutting from the cave floor like the fang of some subterranean beast. Dubbed the Mars stalagmite, this eerie formation sent conspiracy theorists into overdrive, with claims it was everything from an ancient alien artifact to the remnants of a long-dead Martian ecosystem. But before we start drafting blueprints for underground alien civilizations, let's shine a light on what's really casting that ominous shadow. The truth lies in Mars' fiery past. On Earth, stalagmites are typically formed by water. Mineral-rich droplets from cave ceilings leave behind tiny deposits that grow into spikes over millennia. But Mars, its version, is likely forged by something far more volatile: lava. Picture a volcanic eruption billions of years ago, molten rock surging through underground tunnels. As the lava drained away, it left behind clinging remnants that cooled into jagged protrusions, much like the lava stalactites found in Earth's volcanic tubes. Hawaii's Kazumura Cave offers a perfect parallel, with its own glassy, dagger-like formations hanging from ceilings where lava once bubbled. The Mars stalagmite might just be the upside-down cousin of these earthly features, a spike born not from dripping water but from oozing, searing rock. But there's another possibility: wind erosion. Mars' thin but relentless atmosphere has sculpted some of the solar system's most surreal landscapes, and caves are no exception. Over eons, dust-laden gusts could have sandblasted softer rock away, leaving behind harder spines like a stone thorn pushing through the ground. Satellite imagery reveals similar wind-carved spires in places like Chile's Atacama Desert, where ancient volcanic ash has been whittled into razor-sharp pinnacles. The difference: on Mars, without rain or vegetation to soften the process, the erosion is distilled to its most dramatic form. Zooming in on the original image, details emerge that debunk the alien structure hype. The spike's surface is pocked and uneven, its base merging seamlessly with the surrounding rock, hallmarks of natural formation, not precision engineering. Spectral analysis adds another nail to the coffin. The protrusion shares the same mineral composition as the cave walls, lacking any exotic materials that might hint at artificial origins. It's a textbook case of pareidolia, our brains grafting familiar shapes onto random geology, like seeing a face in the moon. Yet for all the scientific explanations, the Mars stalagmite still captivates. It's a reminder that nature doesn't need aliens to create wonder. Whether shaped by fire or wind, this lonely spike is a testament to a planet that spent billions of years experimenting with stone, crafting sculptures that rival our wildest imaginations. And somewhere in the darkness of another cave, another spike might be waiting not as proof of Martians, but as a monument to the raw, untamed artistry of the cosmos. Mars has a way of playing tricks on the eyes, but few illusions are as mind-bending as the so-called floating boulder, a massive rock that appears to hover effortlessly above the Martian surface. When NASA's high-rise camera first captured this anomaly in the rugged terrain of Cerberus Fossae, the image seemed to defy physics. There it was, a house-sized boulder casting a crisp shadow on the ground below, with nothing but empty space beneath it. The internet exploded with theories: anti-gravity technology, alien engineering, or just another one of Mars' relentless optical pranks. The truth, revealed through meticulous 3D terrain modeling, is both simpler and more fascinating. That boulder isn't floating at all. It's perched atop a slender, crumbling pillar of rock, one so perfectly aligned with the camera's angle that it vanished into the shadows like a magician's sleight of hand. Think of it like a tablecloth trick. If you snap the cloth just right, the dishes stay put, giving the illusion they're suspended in midair. On Mars, erosion plays the role of the magician. Wind and dust have spent millennia sandblasting the softer rock around the boulder, whittling away everything except a narrow column of more resistant stone. The result, a natural balancing act so precise it looks supernatural. High-resolution scans of the area tell the full story. When scientists reconstructed the terrain in 3 dimensions, adjusting for lighting and perspective, the hidden pillar emerged a fragile stalk of bedrock barely wider than a school bus. The boulder's weight is slowly fracturing its own support, and one day, perhaps soon in geological terms, it'll collapse, joining the scattered debris littering the valley floor. But for now, it remains suspended in time, a testament to the patient violence of Martian erosion. What makes this formation so mesmerizing isn't just the illusion, it's the process behind it. Unlike Earth, where rain and vegetation accelerate erosion in chaotic ways, Mars relies almost entirely on wind, creating sculptures of eerie precision. Side-by-side comparisons with earthly formations like Utah's Goblin Valley highlight the difference. Our planet's hoodoos and spires are lumpier, shaped by water's unpredictable touch. Mars' versions are sharper, more geometric, as if crafted by an artist with a steadier hand. And then there's the bigger question: how many more of these floaters are out there? Orbital imagery suggests dozens, maybe hundreds, hiding in plain sight, their support pillars camouflaged by shadow or dust. Each one is a ticking clock, a fleeting monument to the forces that built and are still dismantling the red planet. So while the floating boulder isn't proof of alien levitation, it's something just as valuable, a masterclass in how Mars keeps us questioning what we see, and a reminder that sometimes the most extraordinary things are just ordinary geology viewed from the right angle. Among the wind-swept plains of Mars, Curiosity Rover once stumbled upon a scene straight out of a petrified forest: rows of elongated, cylindrical objects scattered across the terrain like logs left behind by some cosmic lumberjack. Dubbed the Mars logs, these bizarre formations bear an uncanny resemblance to fossilized wood, complete with segmented textures and tapered ends that look almost organic. When the images hit NASA servers, they sparked instant debate. Had we finally found proof of ancient Martian forests, or was the red planet pulling another one of its geological sleights of hand? The truth is both less fantastical and no less fascinating. These logs aren't remnants of alien trees, they're the handiwork of Mars' volcanic past. Spectral analysis reveals they're made of basalt, the same dark, dense rock that forms from cooled lava on Earth. But how does volcanic rock end up looking like timber? The answer lies in a process called columnar jointing. When thick lava flows cool, they contract, creating stress fractures that propagate downward in geometric patterns. On Earth, this phenomenon gives us landmarks like the Giant's Causeway in Ireland, where hexagonal pillars stack like a honeycomb. On Mars, the same physics apply, but the results are even more surreal. Without erosion from rain or roots to soften the edges, the planet's basalt fractures into eerily pristine cylinders, their surfaces polished smooth by millennia of wind-blown sand. But there's another twist. Some of the logs appear darker and more resistant to erosion than their surroundings, suggesting they might be erosion-resistant veins of mineral-rich material. Picture groundwater seeping through cracks in the rock billions of years ago, depositing harder minerals like silica or iron oxides. Over time, the softer rock around these veins wore away, leaving behind these rod-like spines. Rover wheel tracks cutting across the scene provide stark scale. Some logs stretch longer than a car, their proportions further fueling the illusion of felled timber. The magic of these formations isn't just in their origin, it's in the way they challenge our Earth-centric perspective. Our brains are wired to interpret elongated, segmented shapes as biological, a bias that turns ordinary geology into extraterrestrial wishful thinking. Side-by-side comparisons with petrified wood from Arizona's Petrified Forest National Park show just how deceptive this can be. Both share fibrous textures and cylindrical forms, but one was shaped by cellular structures, the other by the slow-motion shattering of molten rock. Yet the Mars logs aren't just a lesson in mistaken identity. They're time capsules capturing moments when the planet's fiery interior met its surface in dramatic fashion. Some show faint banding, hinting at multiple lava flows or mineral deposition events. Others cluster in families, their parallel alignments tracing the direction of ancient stress fields like frozen compass needles. And then there's the bigger question. If wind and chemistry can conjure such lifelike illusions here, what else might we be misreading in Mars' rocky record? So while these logs won't burn in any campfire, they light up something just as valuable: our curiosity. Every twisted cylinder is a reminder that Mars doesn't need life to imitate it. The universe has its own toolbox, and on a world where volcanoes once roared and groundwater bubbled through cracks, even the rocks can tell stories that blur the line between geology and fairy tale. Mars' polar regions hold some of the most hypnotic landscapes in the solar system, a labyrinth of cracks, pits, and ridges arranged in near-perfect hexagonal patterns, stretching for miles like some colossal beehive frozen in time. Dubbed the honeycomb terrain, this bizarre geological mosaic has baffled scientists since the first high-resolution images beamed back from orbit. From above, the polygons look almost deliberate, their six-sided cells fitting together with geometric precision that borders on artistry. But this isn't the work of alien architects. It's a masterpiece written in ice, wind, and the relentless tug of Martian seasons. The leading explanation points to seasonal ice fractures. Imagine Mars' poles as a sprawling, frozen lake. During winter, temperatures plummet to -190 degrees Fahrenheit, causing the ice sheet to contract and crack. But unlike Earth, where ice fractures chaotically, Mars' thin atmosphere and consistent climate conditions create startlingly uniform stress patterns. The cracks propagate in 60-degree angles, forming a lattice of fractures that over thousands of cycles of expansion and contraction sculpt the ice into hexagons. Laboratory experiments on Earth support this. When researchers freeze and thaw simulated Martian ice in climate-controlled chambers, identical hexagonal patterns emerge, like nature's version of a cosmic etch-a-sketch. But ice isn't the only suspect. Some researchers argue salt tectonics could play a role. On Earth, vast salt flats like Bolivia's Salar de Uyuni form polygonal cracks as groundwater evaporates, leaving behind crystalline crusts that buckle and split. Mars, with its history of briny groundwater, might have undergone similar processes. Spectral data from orbit reveals traces of perchlorate salts compounds that expand and contract dramatically with temperature shifts, coating the honeycomb cells. If ancient Martian groundwater laced with these salts once seeped to the surface and evaporated, it could have left behind a brittle crust that fractured into these eerie polygons. What makes the honeycomb terrain truly mesmerizing is its scale. Individual cells can span over 50 yards across, their walls standing several feet high. Time-lapse imagery from NASA, a Mars reconnaissance orbiter, shows the patterns evolving over months, with fresh fractures spiderwebbing across the landscape as carbon dioxide ice sublimates into the thin spring air. In some areas, the hexagons cluster so densely they resemble frosted glass. In others, they sprawl like a tiled floor laid by giants, yet the most tantalizing detail lies beneath the ice. Radar scans from probes like ESA's Mars Express have detected liquid water pockets trapped under these polygonal grids, salty, subglacial lakes that might be remnants of Mars' wetter past. Could these hidden oases, shielded from the harsh surface, harbor microbial life? It's a long shot, but the honeycomb terrain suddenly becomes more than just a geological curiosity. It's a potential refuge, a network of icy vaults where the last whispers of Martian biology might still cling to existence, side by side with Earth's own polygonal wonders, from Arctic ice wedges to Utah's salt-cracked playas. The similarities are striking. But Mars' version is sharper, more exaggerated, as if the planet took a terrestrial process and dialed it up to 11. The honeycomb terrain isn't just a frozen snapshot, it's a dynamic engine, still reshaping itself with every passing year. And as we stare down at those perfect hexagons, we're not just seeing cracks in ice. We're reading a diary of climate change written over millennia, one where every line holds a secret, and every cell is a chapter in Mars' slow, silent story of survival. One of Mars' most surreal sights isn't something on the surface, it's something missing from it. Enter the Mars jellyfish, a peculiar depression etched into the planet's south polar region, surrounded by sprawling, shadowy streaks that fan outward like ghostly tentacles. When high-rise NASA, a high-resolution orbital camera, first captured this formation, its eerie resemblance to a sea creature floating in the void sent researchers scrambling for answers. But this isn't the work of alien ocean life. It's a signature of something just as mesmerizing: dry ice skating across Martian terrain in a slow-motion ballet of sublimation and wind. The secret lies in Mars' seasonal dance of ice and gas. During winter, the poles become burial grounds for carbon dioxide, with dry ice accumulating in layers up to several feet thick. But when spring sunlight creeps in, the ice doesn't melt. It vanishes, transforming directly from solid to gas in a process called sublimation. This isn't a gentle thaw. Trapped gas builds pressure beneath the ice until it finds weak spots, bursting through in geysers that blast dust and debris high into the thin atmosphere. The jellyfish's tendrils are the scars of this explosive escape, dark streaks left behind as gas and dust cascade down slopes, carving sinuous channels in the underlying terrain. High-rise time lapses reveal the drama in action. Watch the sequence and you'll see the jellyfish emerge, fresh tendrils unfurling like ink in water as the season shifts. Each streak traces the path of a mini avalanche where tiny particles once trapped in ice ride the gas flows downhill, the depression at the center. That's the escape hatch, a pit where the ice cracked open and the great exhale began. Overlay these animations with thermal data and the pattern clicks. The darkest streaks align perfectly with the warmest slopes where sunlight triggers the most violent sublimation. But why jellyfish? The illusion comes down to fluid dynamics. On Earth, sinking dense fluid creates similar shapes. Think of paint dripping into water or smoke curling from a candle. Mars' low gravity and thin air stretch these processes into slow, exaggerated forms. The result is a haunting hybrid, part avalanche, part geyser, part art. And it's not alone. Nearby, hundreds of smaller jellyfish dot the landscape, their tendrils overlapping like a school of spectral medusae frozen mid-swim. What makes this phenomenon so captivating isn't just its beauty, it's the way it reshapes our understanding of Mars as a living world. These aren't static scars, they're seasonal performances rehearsed over millennia. Every spring, the jellyfish reappears, its tendrils lengthening, its pit deepening, a reminder that even in the coldest corners of the solar system, change is the only constant. And somewhere beneath that ice, who knows what other secrets wait to break free? Mars isn't just a world of eerie silence, it might also be a planet that sings. Among its vast deserts, scientists have theorized the existence of booming dunes, colossal sand mountains capable of producing low-frequency vibrations that rumble like distant thunder. These hypothetical Martian choirs would mirror Earth's own sonic dunes, where certain sands produce haunting, musical notes when disturbed. But here's the catch. Mars' thin atmosphere could turn this cosmic concert into something far stranger, or silence it altogether. On Earth, booming dunes are rare but well-documented marvels. Places like California's Kelso Dunes or the Namib Desert emit deep, resonant tones when sand avalanches down their slopes. The phenomenon hinges on two factors: grain size and atmospheric pressure. The sand must be exceptionally round and uniform, allowing grains to slide past one another with synchronized vibrations. As they tumble, they create cascading collisions that amplify into sound waves. Think of it like a million tiny tuning forks vibrating in unison. Earth's thick atmosphere acts as a conductor, transmitting these vibrations as audible booms that can last for minutes and carry for miles. Now imagine that same process on Mars. The red planet's dunes, some towering over 600 feet tall, seem like perfect candidates for extraterrestrial soundscapes. But there's a cosmic twist. Mars' atmosphere is just 1% as dense as Earth's. Sound waves struggle to propagate in such thin air, dampening higher frequencies and leaving only the deepest, most guttural vibrations. Any song from Martian dunes would likely be infrasound frequencies so low human ears couldn't detect them without instruments. It'd be less like a desert choir and more like the planet's slow, seismic heartbeat. Laboratory experiments back up the eerie possibilities. Scientists have recreated Martian conditions in vacuum chambers, tumbling sand samples to simulate avalanches. The results, barely audible murmurs, a far cry from Earth's booming performances. Yet orbital data adds intrigue. Some of Mars' dunes exhibit steep slip faces and fine-grained sands, the exact recipe for sonic activity. Could the right windstorm or Rover disturbance unlock a fleeting, subsonic rumble? The Perseverance rover, equipped with microphones, might finally settle the debate if it stumbles upon the right dune at the right moment. What makes this mystery so compelling isn't just the science, it's the poetry of a world that refuses to be silent. Even if Mars' dunes whisper instead of sing, their potential voice hints at unseen connections between planets. Across the solar system, wind sculpts sand into hills that might hum, crumble, or roar, each note shaped by the air it breathes. And somewhere in those rust-colored deserts, a dune could be waiting to prove that even the quietest worlds have songs we've yet to hear. Strange Thing 24 on our list isn't just an oddity, it's a fleeting, seasonal spectacle that transforms Martian slopes into abstract murals every spring. Meet the recurring slope lineae, or RSLS, dark, finger-like streaks that creep downhill when temperatures rise, then vanish as quickly as they appeared. For years, these enigmatic features fueled hope that liquid water might still flow on Mars, even if just seasonally. The theory was tantalizing briny water, loaded with perchlorate salts to keep it from freezing in Mars' sub-zero chill, oozing to the surface and carving these Inkai trails before evaporating into the thin air. But like so much on Mars, the closer we looked, the stranger the story became. The first clues came from spectral readings. Orbiting instruments detected hydrated salts compounds that only form in the presence of water along the streak's path. This seemed like a smoking gun. On Earth, similar stains appear where salty groundwater seeps through canyon walls, like in Utah's Capitol Reef. Scientists even recreated the process in Mars simulation chambers, showing how briny flows could produce exactly the kind of dark, damp streaks we see from orbit. The implications were staggering. If water was still active near the surface, even intermittently, it could reshape our search for microbial life. But then alternative explanations emerged. High-resolution imagery revealed something unexpected. Many RSLS originated at the crests of dunes, not rocky outcrops where aquifers might lurk. Sand, not water, became the new suspect. Lab experiments showed how dry grains cascading down slopes could produce nearly identical dark streaks, especially if the sand contained iron-rich minerals that contrast with the surrounding dust. The movement, triggered by seasonal shifts in temperature that destabilized loose material, sending mini avalanches skittering downhill. Suddenly, Mars geysers might just be the universe's most elaborate magic trick, a desert pretending to weep. Yet the debate is far from settled. Some streaks behave in ways dry sand alone can't explain. A few flow uphill briefly before reversing, as if guided by some unseen force. Others appear in spots too cold for even briny water to flow, yet still show those telltale hydrated salts. Could it be a mix of both, perhaps sand sliding over thin films of water, too scant to pool but enough to lubricate the grains, or CO2 ice subliming directly into gas, fluidizing the sand like a cosmic air hockey table? The Mars Reconnaissance Orbiter's time-lapse sequences only deepen the intrigue. Watch the streaks lengthen day by day, sometimes branching like veins, other times stopping abruptly as if hitting an invisible wall. They're seasonal performers, returning to the same stages year after year, yet never quite following the same script. And while recent rovers haven't spotted active flows up close, their absence might just mean the phenomenon is stealthier than we thought, a whisper of movement in a world we're still learning to hear. So are these streaks proof of water or just another Martian mirage? For now, they're a reminder that the red planet specializes in blurring lines between the possible and the improbable, the wet and the dry, the living and the dead. Every spring, as those dark fingers stretch across the slopes, they write a fresh riddle in the dust. And one day, whether the answer is water, wind, or something stranger still, it'll rewrite our understanding of Mars all over again. One of the most baffling textures ever photographed on Mars looks like the planet decided to whip itself a cappuccino. Dubbed the Mars Foam, this peculiar rock formation discovered by Curiosity rover in Gale Crater features a surface pockmarked with bubble-like pits and a frothy, almost spongy appearance. At first glance, it resembles the foamy head of a beer or the porous crust of a freshly baked loaf. But this isn't some interstellar bakery mishap. It's a window into Mars' volatile past, where fire and gas once danced beneath the surface in ways we're only beginning to understand. The leading theory points to gas-rich lava. Picture a volcanic eruption billions of years ago where molten rock surged upward, packed with dissolved gases like carbon dioxide and water vapor. As the lava neared the surface, pressure dropped, causing the gases to expand violently, like shaking a soda can and popping the tab. The result, a frothy, vesicular rock that solidified mid-bubble, preserving those chaotic moments in stone. On Earth, similar formations appear in places like Hawaii's Kilauea volcano, where lava bombs often contain hollow cavities from trapped gas. But Mars' lower gravity and thinner atmosphere might have amplified the effect, creating even more exaggerated, delicate foam structures. Yet there's another contender, weathering rinds. Over millennia, chemical reactions between Martian rocks and the planet's scant moisture could have created thin, crumbling outer layers. As wind sandblasted these surfaces, softer minerals eroded faster, leaving behind pitted textures that mimic foam under the right lighting. Curiosity's close-ups reveal mesmerizing details. Some pits are perfectly spherical, while others merge into elongated troughs like bubbles in a sink full of dish soap. Chemical analysis adds another clue. Patches of sulfur and chlorine found in the foam suggest corrosive brines might have played a role, slowly eating away at the rock's surface like cosmic acid rain. The real magic lies in the microscope-like images. Zoom in, and the foam's texture becomes a labyrinth of overlapping voids, some no larger than a pinhead. Shadows pool in the deeper cavities, creating an illusion of depth that tricks the eye into seeing movement, as if the rock might still be bubbling from some long-extinct heat source. Side-by-side comparisons with earthly pumice or volcanic scoria show eerie similarities, but Mars' version is often more uniform, its patterns less chaotic. That consistency hints at environmental differences, perhaps steadier eruption conditions or slower cooling rates under the planet's ancient skies. What makes this discovery so compelling isn't just the scientific debate, it's how the foam challenges our assumptions about Martian geology. We're used to seeing rocks as static relics, but this formation crackles with energy frozen mid-boil. Whether sculpted by ancient lava or patient chemistry, it's a reminder that Mars was once a world of furious activity where even the stones could froth and fizz. And somewhere in that porous matrix there might still be trapped whispers of the atmosphere that helped shape it, tiny time capsules waiting to spill their secrets. Sometimes Mars doesn't just play tricks on our eyes. It sends beams of light straight into the lens, sparking debates that stretch from scientific forums to late-night alien conspiracy threads. One of the most heated mysteries came from a single Curiosity rover image snapped in 2014, where a distant hillside seemed to glow with an unnatural brightness, a tiny pinprick of light standing defiantly against the rusty landscape. At first glance, it looked like a lamppost or a beacon, so out of place that it launched 1,000 theories. Underground civilizations signaling to the surface, reflective alien structures, even a glitch in the Martian matrix. But before we pack our bags for a cosmic road trip, let's shine a light on what's really casting that eerie glow. The most plausible explanation, a cosmic ray hitting the camera sensor. Mars lacks Earth's protective magnetic field, leaving its surface bombarded by high-energy particles from deep space. When one of these particles strikes a detector, it can leave behind bright pixels or streaks like digital static from the universe itself. Curiosity's team has documented this phenomenon before, with similar bright spots appearing in other images before vanishing in subsequent shots. Think of it like a microscopic lightning bolt zapping the camera, a fleeting flash with no physical counterpart on the planet. To test this, researchers overlaid the light's position with lens flare patterns and sensor hotspots. The match was nearly perfect, a dead ringer for a cosmic ray's fingerprint. But here's where it gets even more interesting. The light's appearance coincides with another phenomenon, sunlight glinting off metallic surfaces. Curiosity's own hardware, like screws or antenna mounts, can catch the sun at just the right angle, creating dazzling reflections that pixelate into mysterious dots. Engineers recreated the conditions in simulations, adjusting the rover's position relative to the sun. Sure enough, at certain angles, even a mundane bolt could flare into a beacon. Zoom in on the original image and the illusion unravels. The bright spot lacks any context, no shadow, no surrounding structures, no repeat appearances in photos taken minutes later. Compare it to lens flare artifacts from Earth photography, and the similarities are striking. That alien city light shrinks down to a single overexposed pixel, a trick of optics and radiation rather than extraterrestrial engineering. Yet the stubborn allure of the mystery reveals something deeper. We're wired to seek meaning in anomalies, to turn camera noise into cosmic signals. Mars indulges that instinct, dangling just enough ambiguity to keep us questioning. And who knows, someday, a light on the horizon might not have such an easy explanation. Until then, this tiny spark remains a lesson in how the universe loves to photobomb our search for answers. Even in its craters, Mars has a way of nodding to Earth's pop culture like the uncanny Mars Pac-Man, a perfectly shaped depression that looks like the iconic video game character mid-chomp. Spotted by NASA Mars Reconnaissance Orbiter in the icy lowlands of Noche's Terra, this formation stretches nearly a mile wide, its circular mouth punctuated by a triangular notch that mirrors Pac-Man's infamous wedge. At first glance, it's almost too perfect a playful quirk on a planet usually defined by desolation. But the forces behind this cosmic Easter egg are anything but cartoonish. The most plausible explanation, an oblique meteor impact. Picture an asteroid streaking in at a shallow angle, maybe 15 degrees or less, rather than hitting head-on. Simulations of such impacts show how they can carve asymmetrical craters, with one side collapsing more dramatically than the other. The result, a bowl-shaped depression with a distinctive bite taken out nature's version of a celestial cookie cutter. High-resolution terrain maps reveal telltale clues, debris fields fanning out unevenly from the crater's open side, and subtle ridges where the impactor might have skipped like a stone before fully detonating. But there's another twist, lava. Some planetary scientists argue this Pac-Man could be a volcanic caldera, partially filled by later lava flows that pooled unevenly, leaving one sector higher and more intact. Mars' history of fiery eruptions lends credence to this idea. If lava oozed into the crater's base but failed to fully submerge it, the remaining rim could form that signature wedge. Spectral data adds fuel to the debate. The crater floor shows mineral signatures consistent with both impact melts and volcanic basalt, leaving room for interpretation. To visualize the process, imagine pouring pancake batter into a bowl but tilting it slightly. The batter thickens on one side, leaving the opposite edge exposed. Now scale that up to planetary proportions, with lava or impact debris playing the role of the batter. The resemblance to Pac-Man isn't just coincidence, it's geometry meeting pop culture in the most unexpected way. Yet the real magic lies in the crater's icy context. Nestled near Mars' South Pole, this Pac-Man isn't just a dry geological oddity, it's a seasonal chameleon. In winter, carbon dioxide frost blankets the depression, turning it into a pale, ghostly outline. Come spring, the frost sublimates away, revealing the dark, sharp-edged mouth once more. Time-lapse orbital imagery captures this transformation like a blinking pixel in an old arcade game. A reminder that even Mars' most whimsical features are part of a dynamic, ever-changing world. So while this crater might not be a beacon for hungry aliens, it is a testament to the universal language of shape and shadow. From a certain angle under the right light, even the cosmos can't resist a wink at nostalgia, and Mars, it seems, has a flair for comic timing. Mars has a way of weaving Earth's familiar imagery into its alien landscapes, and few illusions are as striking as the so-called Mars trees. In images captured near the planet's North Pole by NASA, a high-rise orbiter, dark, spindly tendrils stretch across the dunes like a dense forest sprouting from the rusty soil. For those who dared to dream, the resemblance was uncanny. Gnarled trunks, sprawling branches, even shadows that seemed to stretch like late afternoon silhouettes. But the truth behind these trees is even more fascinating, because they're not trees at all. They're fleeting fingerprints of an invisible force written in dust and ice. The magic begins beneath the surface. During Martian winter, temperatures at the poles plummet so low that carbon dioxide freezes directly out of the thin air, blanketing the dunes in a layer of dry ice several feet thick. But when spring arrives and sunlight pierces the translucent ice, something extraordinary happens. The ice doesn't melt, it sublimates, transforming from solid to gas without ever becoming liquid. Trapped beneath the frozen slab, this gas builds pressure until it finds weak spots, bursting through in explosive jets that blast dark basaltic sand high into the air. As the sand rains back down, it cascades across the pristine ice in rivulets, carving dendritic patterns that mirror the veins of a leaf or the branches of a tree. From orbit, these streaks become an optical illusion, a phantom forest swaying in a wind that doesn't exist. Side-by-side comparisons with Earth's own dune dynamics reveal just how deceptive perspective can be. In places like Namibia's Sossusvlei or California's Kelso Dunes, avalanching sand creates similar dark streaks down slip faces. But on Earth, these are short-lived, erased by rain or trampled by vegetation. On Mars, without interference, the patterns linger for months, their Inkai trails preserved like ink on parchment. High-resolution time lapses from high rise show the trees growing, new tendrils creeping downhill as fresh gas eruptions rupture the ice, each outburst adding another stroke to nature's ephemeral canvas. What makes this phenomenon so mesmerizing isn't just the illusion, it's the physics behind it. The branches aren't random, they follow the path of least resistance, branching at predictable angles as the sand seeks equilibrium. Scientists call this diffusion-limited aggregation, a process seen everywhere from lightning bolts to coral growth. But on Mars, the effect is distilled to its purest form. No moisture, no roots, just granular material obeying the universe's unspoken rules. Close-ups reveal even finer details. Some streaks fray at the edges like frayed rope, while others taper to needle-thin points, their forms dictated by the size of the escaping sand grains. Yet the real wonder lies in how fleeting it all is. As summer intensifies, the ice vanishes entirely, and with it the phantom forest. The dunes return to their barren state, waiting for winter's frost to set the stage anew. It's a reminder that Mars isn't just a static museum of rocks, it's a stage for seasonal performances, where even the most convincing illusions are just part of the show. And somewhere in another hemisphere, another forest might already be stirring, ready to bloom in the stark light of a distant sun. The so-called Mars Cube became an overnight sensation when China's Zhurong rover spotted a peculiar geometric shape looming on the horizon, a stark, angular silhouette that seemed to defy the planet's otherwise chaotic terrain. Framed against the rusty plains of Utopia Planitia, the object looked almost deliberate, its sharp edges and flat faces evoking everything from monoliths to alien artifacts. Social media erupted with theories, from ancient ruins to secret structures, as if Mars had finally decided to drop its most blatant hint yet. But as with so many Martian mysteries, the truth was hiding in the pixels themselves. High-resolution follow-up images revealed the cube for what it truly was, a completely ordinary rock outcrop, its angles exaggerated by distance, lighting, and the limitations of early camera shots. The rover's initial vantage point, combined with the low sun angle, cast long shadows that sharpened the formation's edges into an illusion of perfect geometry. Later close-ups dismantled the fantasy. What appeared to be a flawless cube from afar was just a weathered mesa, pockmarked and uneven like any other Martian boulder. The magic lay in pareidolia, our brain's relentless habit of imposing order on randomness, especially when viewing something at the edge of resolution. Yet the cube's brief moment in the spotlight wasn't just about debunking a myth. It highlighted a fascinating quirk of Martian geology, the way wind erosion can mimic precision. On Earth, similar optical illusions occur in places like Egypt's western desert, where distant rock formations take on uncanny geometric shapes under certain light. But Mars, with its thin atmosphere and relentless dust storms, amplifies the effect. Wind doesn't just smooth surfaces, it sculpts them with a patient, almost algorithmic consistency, sometimes creating edges so crisp they look machined. Side-by-side comparisons of the original cube image and the follow-up shots are revelatory. The first frame, grainy and backlit, turns a jumble of rocks into a sci-fi prop. The second, crisp and sunlit, reduces it to mundane geology. But the real lesson here isn't just about cameras or angles, it's about how exploration unfolds. Every new rover, every sharper lens chips away at Mars' mysteries, not by dismissing them, but by revealing deeper layers of complexity. What starts as a cube becomes a cliff, then a chemical puzzle, then a clue about ancient winds or water. So while the Mars cube wasn't a gateway to another dimension, it was something just as valuable. A reminder that the red planet's greatest trick isn't hiding secrets, it's convincing us to look closer, question harder, and marvel at how much wonder remains packed into the ordinary. And somewhere out there, another cube is waiting, not as proof of aliens, but as a testament to the human hunger for discovery and the universe's endless talent for keeping us guessing. The internet has a way of turning shadows into legends, and nowhere is that more true than with the so-called Mars Yeti. This blurry, indistinct figure supposedly appeared in a rover image, lurking in the background like some cosmic cryptid. At first glance, the smeared silhouette does have an uncanny resemblance to a hunched, shaggy creature, perhaps a distant cousin of Bigfoot who took a wrong turn at Jupiter. But before we start drafting expedition plans to bag the galaxy's most elusive game, let's break down how Mars keeps tricking us into seeing things that aren't there. The Yeti owes its existence to two Martian specialties, pareidolia and pixelation. Pareidolia, our brain's habit of imposing familiar shapes on random patterns, is the same quirk that makes us see bunnies in clouds or faces in electrical outlets. On Mars, where lighting is harsh and shadows stretch unnaturally long, even a jagged rock can morph into a looming figure if the angle's just right. Now add in the limitations of early rover cameras. Lower resolution images compress details, turning indistinct blobs into tantalizing evidence. Zoom in on the original shot, and the Yeti dissolves into a completely unremarkable boulder. Its arms just shadows pooling between uneven ridges, its posture a trick of perspective against the horizon. What's fascinating isn't the debunking, it's the fervor the illusion inspired. The Yeti became a meme, photoshopped into pop culture references ranging from ski resort logos to horror movie posters. It tapped into something primal, the thrill of the unknown, the hope that Mars might still hide something alive, even if just in our imaginations. Scientists lean into the joke too. One NASA team even joked about spotting the Yeti's footprints in nearby dunes. Spoiler, they were just wind ripples. But here's where the story gets richer. This isn't the first creature spotted on Mars. Over the years, eagle-eyed enthusiasts have discovered everything from Martian crabs to crouching humanoids, each one dissolving under scrutiny into rocks, dust, or camera artifacts. The Yeti is just the latest in a long tradition of cosmic Rorschach tests, side-by-side comparisons with earthly pareidolia, like the famous face on Mars or Chile's Atacama alien skeleton, actually a mummified human child, reveal how consistent our pattern-seeking brains are across context. So while the Mars Yeti isn't real, its legacy is. It's a testament to how a sprinkle of ambiguity and a dash of humor can transform science into shared storytelling. And somewhere out there, another rock is waiting to become the next interstellar legend, not because Mars is hiding monsters, but because we'll never stop looking for them. From the haunting ghost dunes to the uncanny Mars jellyfish, the sheer variety of these 30 discoveries proves one thing: Mars is anything but predictable. Each strange formation tells two stories, the scientific explanation grounded in wind, water, and time, and the irresistible human urge to see more. Whether it's pareidolia turning rocks into rats or geology sculpting perfect hexagons, the red planet keeps blurring the line between reality and imagination. Take the blueberries' tiny hematite orbs that once hinted at ancient groundwater, or the dragon scales etched by volcanic fury or briny flows. Even the face on Mars, now debunked as a mesa, reshaped how we explore, teaching us to question shadows while staying open to wonder. Every mission peels back another layer, revealing a world that's less a dead wasteland and more a dynamic archive, its pages written in cracked ice and petrified lava. Yet the biggest mystery isn't any single anomaly, it's how Mars continues to surprise us. Just when we think we've cracked its code, it serves up something new, a floating boulder here, a singing dune there. That's the real magic, with missions like NASA Mars Sample Return and ESA's ExoMars Rover on the horizon. Who knows what else we'll uncover? Maybe one day we'll find an answer that doesn't fit the textbook, a discovery that rewrites everything. So here's the invitation. Scroll back through these 30 enigmas and tell us which one captured your imagination. Was it the jellyfish terrain where gas writes in dark ink, or the cannonball that rolled through time? Drop your favorite in the comments, and if you're craving more cosmic mysteries, hit subscribe. The universe has endless stories left to tell, and Mars, it's just warming up.